Today I am going to discuss about the quicksand condition. This is a gravity dam, and this is the upstream side of the gravity dam, and this is the downstream side of the gravity dam. We know that water flows from the higher head to lower head. When water flows through the higher head to lower head, and we have previously studied that the seepage will occur through the soil, and the direction of the seepage is the direction of the along the direction of the flow. And the seepage will occur under the foundation of the gravity dam. Here the upstream side and this is the downstream side. So flow in the direction of downward. Here the flow is in the direction of downward. Flow is downward. When flow is downward, the seepage will occur in downward direction. Seepage is in downward direction. This is the case of downward flow condition. When in downward flow condition, the effective stress increases. But in this side, in the downstream side, the flow is upward. As a result of seepage is upward, seepage is also in upward direction. Previously we studied that when the seepage is in upward direction, the flow condition is known as upward flow condition. In upward flow condition, we have studied that effective stress is the submerged unit weight of soil into Z minus Iz gamma W. Where Iz gamma W is the total term of the, we can totally call it is seepage pressure. Seepage pressure will be more when this is hydraulic gradient is more, that is I. Hydraulic gradient is more means that is head difference, either head difference is more or the flow length is more. Here the head difference is much more, hence the hydraulic gradient is more. When the hydraulic gradient is more, the seepage pressure is also more. That's why it takes away the soil in the downstream side, and as a result of decreasing the flow line. When the flow line decreases, the hydraulic gradient is also increases. When the hydraulic gradient is increases, it makes more discharge or more velocity. That's why it creates a pipe-like structure. Or pipe-like wide open structure, which is known as piping. When will the piping occur? If the seepage pressure is equal to the submerged weight, then the effective stress becomes zero. When seepage pressure equal to the submerged weight, then the effective stress equal to zero. As you know, effective stress is a part in the shear strength. And shear strength C plus sigma s bar tan theta. C4 is the cohesionless. Here the soil is quicksand condition occurs in the cohesionless soil or coarse silt. So the value of C is 0, and here the effective stress also 0. So shear strength in this cohesionless soil is 0. When the shear strength is 0, the soil starts flowing with the water. then particles, we can write particles with the soil mass. Particles reach the soil mass and start flowing with the water in the downstream side of the gravity dam. Water in the downstream side. This is known as sand boiling or quicksand condition. Quicksand condition is not a type of sand. It is a condition occurs in the cohesionless soil or coarse silt. The term sand boiling, it refers or it shows that when the water flows in the downstream direction, it displaces the cohesionless soil particles from the soil mass. So it looks like sand boiling. That's why its name also known as sand boiling. When it will occur? When we know that we have studied that effective stress equal to 0. When effective stress equal to 0, then gamma submerged Z minus I Z gamma W equal to 0. Then we can write gamma submerged Z equal to I Z gamma W. This implies I, we can write gamma submerged Z by gamma W Z. Gamma submerged Z, that it means submerged weight by or seepage force by gamma W. So I, here the I is the exit hydraulic gradient, and when the quicksand condition occurs, that moment the hydraulic gradient is known as critical hydraulic gradient. When the exit hydraulic gradient is equals to the critical hydraulic gradient, then at that time the quicksand condition occurs. So we can write, if I is less than IC, then this is the condition of stable condition, or no quicksand condition. If I equal to IC, this is the condition of critical condition. If I is greater than IC, then this is the condition of quicksand condition. To prevent the quicksand condition or piping failure under the foundation of the gravity dam, we must sufficiently provide the factor of safety. The factor of safety we can calculate from the IC by I, where IC is the critical hydraulic gradient, I is the exit gradient. If the exit gradient is equal to or more than the critical gradient, then the quicksand condition occurs. Or we can also write here the total downward force, and if the total upward force is more than the total downward force, then quicksand condition will also occur. So we can write in terms of downward force by upward force. So we can write it FOS nearly equal to 1. If FOS nearly equal to 1, then there is no quicksand condition. If FOS is less than 1, then there is a condition of quicksand. And if FOS is greater than 1, then the structure is stable. To prevent the piping failure, we have some methods. That is, we can provide at downstream side. We can provide the inverted filter or drainage filter or seat piles. We have already discussed about the flow condition and quicksand condition. Now we are discussing about the preventing the piping failure. Now we are talking about the providing the seat piles. The main aim is to provide the seat piles to increase the flow length. If we increase the flow length, we know that that is hydraulic gradient is nothing but the head loss, that is delta H upon flow length. If flow length is more, then critical hydraulic gradient will decreases. If the critical hydraulic length is decreases, then seepage pressure is also decreases. If the seepage pressure is decreases, then we get the adequate amount of factor of safety. So there is no piping failure. In this class, we have learned that quicksand condition and how to prevent the piping failure in the earthen gravity dam. Okay, thank you class.